Hello students, welcome you all to the online video lecture on course Turbo Machines. So we are discussing about the introduction to the turbo machine, that is module number 1. This is a second lecture on the first module of course Turbo Machines. In the first lecture, we have seen the definition of turbo machine, the different parts or principal components of turbo machine, and also we have seen the comparison between turbo machine and the positive displacement machine. In the today's session, we will see the classification of turbo machines, dimensionless parameters, and their physical significance. Okay, let's start our session. Let's start with the classification of turbo machines. Okay, still, if you have not subscribed my channel, so kindly subscribe the channel, like and share among your friends. Okay, so let's start the lecture number 2 with the classification of turbo machines. So turbo machines are classified into various types based on the various factors or parameters. The first classification is based on, it is according to the energy consideration, according to the energy consideration. So based on this, we have two types in turbo machine. The first one is power absorbing turbo machine and the second one is power producing turbo machines. So one should have the clear difference between these two. So the first one is power absorbing turbo machines. The turbo machines transferring rotor energy to the fluid energy, that is the machines supplies the energy to the fluid. For examples, pumps, fans, blowers, compressors, centrifugal pumps, etc. Okay. In case of power absorbing turbo machines, the mechanical energy is supplied, which is in the form of rotation of shaft, and that mechanical energy is used to produce the fluid power or fluid energy. It may be in the form of pressure or it may be in the form of head. Okay, the best example is centrifugal pump or domestic pump, which is used to supply the water from bottom level to the top level at the expense of mechanical energy. So such device or such type of turbo machines are categorized into the power absorbing type turbo machine. The another example is selling fan. Okay, so in fan, at the expense of mechanical energy, we are getting the high pressure air at the outlet. So that means the mechanical energy is converted into the pressure energy of the fluid. Okay, similarly, we have pumps, blowers, fans, compressors, etc. So these are some examples to the power absorbing turbo machines. The second type is power producing turbo machine. It's a reverse. Okay, so just it is a reverse of power absorbing turbo machines. So in case of power producing turbo machines, the fluid power, it may be in the form of the high velocity or high kinetic energy fluid, or it may be high pressure fluid. Okay, whatever it may be, the fluid energy is converted into useful mechanical work, which is in the form of rotation of shaft. Okay, so in power producing turbo machines, at the outlet, we are getting mechanical energy in the form of rotation. Okay. So turbo machines transferring the fluid energy to the rotor energy, so that machines that extract the energy from the fluid are known as the power producing turbo machines. The best examples are turbines. So turbines are the best examples for power producing turbo machines like steam, water turbines, gas turbines, etc. If we consider the example for water turbine, so water turbine is a device which converts the fluid energy, high pressure or high kinetic energy, fluid energy into the mechanical energy, which is of course in the form of rotation. Okay, so all the types of turbines are comes into the category of power producing turbo machines. Okay, the next classification is based on according to the direction of flow, according to the direction of flow. The first one is radial flow turbo machines. The best examples are centrifugal pump. The best example are centrifugal pumps. And the second one is axial flow turbo machines. The examples are axial flow pump, compressors, turbines, etc. Okay. So here, according to the direction of fluid flow, we have the two types. The first one is radial flow turbo machine. Here, in case of radial flow turbo machine, let us take the example for this radial flow fan or radial flow turbo machine. So here the fluid will enters the turbo machine in radial direction, and it comes out through the impeller in the radial direction. Okay, so the rotation of fluid takes place in radial direction. It's called the radial flow turbo machines. The best examples for these are centrifugal pumps, radial flow fans, and centrifugal compressors, etc. Okay, on the other side, on the other side, the second one is axial flow turbo machines. In axial flow turbo machines, the fluid flows in the direction parallel to the axis of rotation of shaft. Parallel to the axis of rotation of shaft. Okay. So let us consider this axial flow compressors. This is a shaft, or this is a runner over which the rotors are mounted, or over which the blades, moving blades are mounted on the periphery of the runner. So as the runner rotates, the suction is created at the inlet, and hence the air will flow in this direction, okay. So this direction is just a parallel to the axis of rotation. This is the axis of rotation, okay. This is the axis of rotation, fine. This is the axis of rotation, and the direction of flow of the fluid is in this direction, okay. So the axis of rotation and the direction of flow of the fluid, they are parallel to each other, they are parallel. So that's why such type of turbo machines are known as the axial flow turbo machine, okay. On the other set, we have some other examples like tangential flow turbo machines. Tangential flow turbo machines, the best example for tangential flow turbo machine is Pelton wheel. A little consideration shows that this is a shaft, this is a runner, and over which we have number of blades which are mounted on the periphery of the runner, okay. So this is the nozzle which converts the pressure energy of the fluid into high velocity jet, okay. So when the high velocity jet is impinging, a little consideration shows that this is in tangential direction. Say for example, this is the rotor, this is the runner, and if the direction of flow of the fluid is in this direction, now can't we say this is the tangent to this circle? Can't we say this is the tangent, this line is tangent to this circle? Yes, the direction of flow of the fluid is in tangent to this rotation of the runner, or rotation of the okay, rotor. So this such type of turbines are known as such type of turbo machines are known as the tangential flow turbo machines. The tangential flow turbo machines. So this is the very important question which will be asked in your examination, okay. What are the examples? Give the example for tangential flow turbo machines. The best example is Pelton wheel turbine. The best example is Pelton wheel turbine, okay. I hope this is clear. We can add one more sentence here. We can add one more sentence here, that is c that is tangential flow turbo machines. Tangential flow turbo machines. Based on this, the examples are based on this the examples are Pelton wheel turbine. Pelton wheel turbine, okay. Pelton wheel turbine, fine, okay. I hope this is clear. Now let's go to the next important classification. According to the action of flow, action of fluid on the moving blades. According to the action of fluid on the moving blades. The first is impulse machine. The first is impulse machine. Fluid energy is converted into impulsive force by changing the direction of fluid. By changing the direction of fluid. So the best example is in steam turbines, we have a de-Laval turbine. De-Laval turbine is the best example for impulse type turbo machines or impulse type turbine. Similarly, the Pelton wheel also the example for impulse type machine. Now let me explain what do you mean by this impulse force or impulse type machines. Impulse type machines. Okay, impulse type machines. Let us consider the example of a Pelton wheel turbine. Now here at the nozzle, the pressure energy of the fluid, the pressure energy or the potential energy of the fluid is completely converted into is completely converted into kinetic energy is completely converted into kinetic energy. I repeat it once again. In case of impulse type turbo machines, the complete pressure energy of the fluid is converted into kinetic energy at the inlet. So whatever the energy of the fluid which is experienced by the fluid is a kinetic energy or high velocity jet. Okay, so the fluid will not experiences any the pressure energy or the potential energy. So remember guys, in case of impulse type, the complete pressure energy of the fluid is converted into high velocity jet or kinetic energy. Okay, so the best examples in case of steam turbines are de-Laval turbine, and in case of hydraulic turbine, it is the Pelton wheel turbine. Okay, so based on the fluid used, that steams are the turbines, the turbo machines are classified into various types. Okay, so if we use the steam as a working fluid, it is a steam turbines. If we use water as the working fluid, it is called hydraulic turbines. If we use gases as the fluid working fluid, then it is called the gas turbines. Okay, so sometimes in the competitive examination, he will ask that, so give the examples for impulse type steam turbine. Give the examples for impulse type steam turbine. This is a very frequently asked question in SSC exams, railways exams for the post of junior engineer. Okay, so sometimes he has asked this question as well. Give the examples for impulse type steam turbine. Impulse type steam turbine. The best example is de-Laval turbine. The best example is de-Laval turbine. Similarly, give the example for impulse type water turbine or impulse type hydraulic turbine. The Pelton wheel is the best examples for the impulse type hydraulic turbine. Kindly note down these important points that will be very helpful in order to crack the competitive examinations. Okay, so these are the very frequently asked questions in exams. Okay, fine. So the second one is reaction turbine. The pressure energy of the fluid is continuously drops as it flows over the blades, and the velocity increases Okay, so let me tell you here that in case of reaction turbine, say for example, these are the sets of moving blades and fixed blades. These are the sets of moving blades and fixed blades. And the first we have set of fixed blades. In the first we have set of fixed blades. These are the fixed blades. And the next one, these are the moving blades. Next one, these are the moving blades. Okay, these are the set of or the row of moving blades. Again, we have the set of fixed blades. Okay, this continues. It depends on the application and the power requirement. So for our convenience, let me consider a single stage. So these two together constitutes a single stage. Okay, the set of fixed blade and the set of moving blade together constitutes a single one stage. Okay, now, in case of reaction turbine, as the fluid flows over the fixed blades, there is a change in direction. The fluid will experience a change in direction, and hence, very importantly, a part of pressure energy is converted into high velocity jet. And whatever the fluid which is coming out from fixed blade, listen here carefully, whatever the fluid which is coming out from the first row of fixed plate, it experiences both pressure energy, pressure energy plus kinetic energy, pressure energy plus kinetic energy. Okay, pressure energy plus kinetic energy. What I mean to say is, as the fluid flows over the blades, flows through the blades, there is a continuous drop in pressure. And as it moves over the moving blades, there is also continuous drop in pressure energy. Okay. But in case of impulse type, the in the nozzle itself, the complete pressure energy of the fluid is converted into high velocity jet. But the case is different in case of the reaction turbine. A part of pressure energy is converted into high velocity jet, and as the fluid moves over the set of blades, there is a gradual decrease. There is a gradual decrease in pressure energy. Okay, so this is called. This is the brief introduction about the reaction turbine. Okay, so why we have to use these reaction turbines means as the fluid leaves the set of moving blade, it experiences the back pressure, it experiences the back force, which is also responsible for rotation of the moving blades. So there are two types of forces are acting over the moving blades. The first force is due to the kinetic energy plus pressure energy experienced by the fluid which is coming out from the fixed blades. Also, when the fluid is leaving the moving blades, it also produces the back pressure, which is also responsible for rotation of the shaft. Okay, so that's why in most of the practical applications, the reaction turbines are preferred. The reaction turbines are preferred. Okay, it's not a pure reaction, it is a mixed type. Okay, impulse reaction turbines are basically used in power plants. Okay, so this is the very brief introduction about the reaction turbine, and hence we learned what are the differences between the impulse turbine and the reaction turbine. Okay, so the fluid leaving the blades will exert a reactive force in the backward direction. So as I explained, when the when the fluid is leaving the set of moving blades, it also exerts the back pressure, which is also responsible for moving the blades. Okay, in the backward direction. Okay, so this reactive force sets a blade in motion. Okay, fine. The best examples are in steam turbines, the best examples are Parsons reaction turbine. The Parsons reaction turbine. So please remember, guys, in case of so if we are dealing with the impulse type steam turbine, De Laval turbine is the best example for impulse type steam turbine. Okay, but reaction type steam turbine, the best examples are Parsons reaction turbine. Parsons reaction turbine. This is about the steam turbines. But if we talk about the hydraulic turbine or water turbines, the best examples are Francis turbine, Kaplan turbine, and propeller turbine. Francis, Kaplan, and propeller turbines are the best examples for reaction type hydraulic turbine or reaction type water turbine. Okay, I hope this is clear. Okay, so these are the very important things that will be asked in the competitive exams like GATE, railways, SSC, and state level competitive examinations. Okay, these are very important points that I have discussed. Okay, the next classification is open or extended machine. The best examples are fans, windmills, or okay, ceiling fans. Okay, so open or extended machines are, listen here carefully, the turbo machines in which we are not using any casing or housing. We are not using any casing or housing. Okay, so in the first lecture we have discussed the casings are also important part of any turbo machine. Okay, so if we consider, say for example, this is a centrifugal compressor, this is the runner or rotating part, these are the blades, these are the fixed blades, and this is called the casing, the outermost part in which the runner is located is known as the housing or casing. Okay, now if we don't use any housing or casing, then such type of turbo machines are known as open type or extended type turbo machines. The best examples are fan. A ceiling fan is the best example for the open or extended type turbo machine. On the other side, the second type is the closed type turbo machine. The closed type turbo machine, it's very simple. If we use the housing or casing which encloses the entire rotating part is known as the closed type turbo machine. The best examples for this are centrifugal compressor, radial flow fan, centrifugal pump, Francis turbine, okay, steam turbines. For all, we have to use the casing which provides the proper direction for the fluid flow, which provides the proper direction to the fluid flow. Is that clear? Okay. So the next important classification is according to according to the type of fluid handled. According to the type of fluid handled, the first one is water turbine or water turbo machines. Remember guys, if we are using the water as a working fluid in turbo machines, and then such type of turbo machines are known as hydraulic turbo machines. Okay, the best examples are Francis turbine, Pelton wheel, Kaplan turbine, okay, centrifugal pumps, etc. Fine. Next one is steam turbine. The best examples are the steam turbines. Okay, the D Laval turbine is the best example for steam turbine, and the Parsons reaction turbine. These are the two examples for the steam turbines, where the high pressure, high temperature superheated steam is used as a working fluid. Okay. Next, the third classification is the third type is air or gas turbine. The best examples are fan, ceiling fan. Fan is the best example for the air or gas turbines, where we are using air as a working fluid, right? Similarly, compressors, blowers, gas turbines. So these are the basic examples for the turbo machines, the gas or air or gas type turbo machines. Is that clear? So this is the most expected question in exams. The question will be like this: define turbo machine and give the classification of turbo machines. So this discussion is also important from your the competitive examination point of view. I tried my level best to discuss more and more points which is asked in the previous year competitive examinations as well. Okay, fine. So the next one is dimensional analysis or application of dimensional analysis to the general fluid flow. So this will be discussed in the next video lecture. Okay, thank you. And please don't forget to like the channel, share the channel, and subscribe the channel. Watch this video completely, and if you have any doubt anywhere, any difficulties, put your comments in the comment box. Okay, and if you have not pressed the bell icon yet, so press the bell icon so that whenever I put a new video on YouTube, you will get the notification instantly. So stay safe, stay healthy. Thank you, and have a nice day.